How can we tell if a number is divisible by 3 or 9? Well, if it's divisible by 3, it's a multiple of 3. 3, 6, 9, and you can see some of the multiples of 3 here. But we need a rule because we may not always have this here, or we may not know them. So what we do is we think of a rule that we know to be true. We don't have to prove it, but for these numbers, these are all divisible by 3 because they're some of those multiples. And the rule says, if they're divisible by 3, the sum of their digits will also be divisible by 3. So let's have a look at a couple. 3 is divisible by 3, 6 is, and the sum of the digits means we add all of the digits together, and that only has the digit 6. Same with 9. Now when we get to 12, we can actually see what that means because we add 1 plus 2, which gives us 3. That's divisible by 3. 1 plus 5 gives us 6. That's divisible by 3. 24, 2 plus 4 is 6, and that's divisible by 3. So that's our rule. All of the numbers that are divisible by 3 have the sum of their digits divisible by 3. 42, 4 plus 2 equals 6. What about one of the other ones? We know that 87's a multiple of 3, so it must be divisible by 3, and we can see that 8 plus 7 is 15, and when we get 2 digits, we can then add those two together until we get a single digit. So we keep adding. 1 plus 5 equals 6, and that's divisible by 3. So 87 is divisible by 3. What about 824? 8 plus 2 is 10, plus 4 is 14. So we've got 2 digits. Let's keep adding them. 1 plus 4 equals 5. 5 is not divisible by 3. We can't share it equally into groups of 3 or 3 groups. So 824 is not divisible by 3 because the sum of its digits is not divisible by 3. How are we going to know if something's divisible by 9? Well, when a number's a multiple of 9, 9, 18, 27, it is divisible by 9. So what's its special feature? These numbers are all multiples of 9, so they're divisible by 9. And we can see that the sum of their digits is actually going to be divisible by 9 as well. So it's very similar to divisible by 3, but the sum of the digits must be divisible by 9. Well, 9's divisible by 9. If we add those 2 digits, 5 plus 4 is 9. 8 plus 1 is 9. So that means it's divisible by 9. What about 99? 9 plus 9 is 18. And we can actually add that again because we've got 2 digits. So 1 plus 8 equals 9. So we keep adding the digits until we have just 1 digit left. So let's try a few now, comparing them. If we have 19, is it divisible by 3? Well, the sum of the digits must be divisible by 3. 1 plus 9 is 10. So when we get 10, we know that's not divisible by 3, but just to check, we could actually add those 2 digits. 1 plus 0 equals 1. So that's not divisible by 3. Now, is it divisible by 9? Well, to be divisible by 9, the sum of its digits must also be divisible by 9. Well, 1 is the sum of its digits, and that's not divisible by 9. But here's the thing. If it's not divisible by 3, it can't be divisible by 9, because 9 is divisible by 3 itself. What about 108? Well, the sum of the digits is 1 plus 0 plus 8, which is 9. So that is divisible by 3. So that's also divisible by 9. So all numbers that are divisible by 9 are also divisible by 3. But not the other way around. 111, the sum of the digits is 1 plus 1 plus 1, which is 3. But that doesn't mean it's going to be divisible by 9. In fact, the sum of the digits is 3, and that's not divisible by 9. So it only works in one direction. A number's divisible by 3 if the sum of its digits is divisible by 3. A number's divisible by 9, the sum of its digits is divisible by 9. And if it's divisible by 9, it will also be divisible by 3.